Okay, now the next program for writing the verilog code for full adder. Okay, so just you can click this number is a device number is a, just you click on new source. So we are writing the module program for first one. So for full adder, so previously we write a program for half adder. Now we can write the code for full adder program. Just this is a module program means in this module program ఈ మాడ్యూల్ ప్రోగ్రామ్ మనం ఏం రాస్తాం అంటే ఫస్ట్ ఆ లాజిక్ ఎలా వర్క్ అవుతుంది ఓకేనా. సో లైక్ సమ్ కానీ క్యారీ కానీ పర్ఫామ్ చేయాలంటే what is the internal logic behind the corresponding sum. So suppose if in case of the full adder sum of 3, actually full adder means that which performs the addition of 3 numbers. So suppose if you are considering a comma b and c are the variables, the sum of these 3 numbers in case of the full adder is equal to a XOR b XOR c. So that is a logic actually. For carry it produces ab plus bc plus ca. So that kind of the logic can be represented by using the operators that are predefinedly available in case of the verilog code. By using that operators we can represent that logic in the module program. So in case of the test bench means that we can write the different possible ways for the corresponding input 3 variables. How we are giving the different combinations of inputs are given to the corresponding 3 variables to perform the addition of these 3 numbers. Okay, so that is a basic scenario if you want to write the. So first of all we have to write the program for module. So full adder program for the representation. Then I have to click just this is another way of taking the output variables. So input variables is nothing but what are the combinations in kita a comma b, so c, and output is nothing but sum comma carry are the output variables, right? Now just I have to represent the how I am going to use this. So this is module is a keyword that is predefinedly available in the module is a predefined keyword in the verilog and full adder name. So this is a module name. Okay, this is the port declaration. Port means that the variables in case of the corresponding port. So here I have to mention how I am going to use these variables. So input a comma b, that means a comma b comma c. That means I can use the a, b, c and variables as the input variables, and output sum comma carry. So sum and carry variables can be used as the output variables. So that is a representation. Now I have to write the logic for the corresponding full adder. So for that purpose, so we know that generally full adder means that which performs the addition of 3 numbers. So assign is a keyword. Assign sum is equal to in case of the full adder a XOR b XOR c. That means XOR of a comma b comma c, that gives the sum of the 3 numbers in case of the full adder. As well as we have to get the carry assign carry is equal to carry in terms of numerical, carry in terms of logic is equal to ab means that product of a and b can be represented by using the and symbol ab plus. So plus can be represented as a vertical symbol, r means that vertical symbol ab plus bc. So bc, so this is not valid actually. So that means bc can be nothing but product. A product can be achieved by using the and operation. So for that purpose I have to use the and symbol plus ab plus bc plus ca. Next ca, so ca is nothing but product. So c and a product can be carried out by using the and operation. So for basically and operation can be carried out using this symbol. Okay, so now sum of a b c can be carried out by using the XOR of a b c, and carry can be calculated by using ab plus bc plus ca. So this is just a code for the full adder in case of the module program. So this is only a simple two lines of the code. Just you have to select this one, implementation. So In case if you want to write the program in case of the module program, just you have to click the implementation. Implementation means that we can write the how the logic is going to be performed in case of the full adder. So for that purpose, just you have to select full adder and check syntax. This code is semantically correct or not. So for that purpose, we have to check the corresponding syntax. If the syntax is good, everything is fine in this code, no mistakes are there, no errors are there, obviously it can be represented in the form of a green colored tick mark. So that is the important thing, right? Let us check. Fine, this code is correct. Now you have to write the test bench. That means you can give the different possible ways for the input possible ways to the full adder. So for that purpose, you have to write the test bench program. Therefore, you have to select verilog test picture. Then you have to name the test bench. So we are writing the full adder. So full adder test bench program. So for our representation point of view, just to click, then you have to select full adder, obviously, so it is predefined. In case if it is not selected, you have to select the corresponding module, which module you are going to write the test bench. So next, finish, zoom it. So here time scale means that obviously delay can be represented as 100, like hash 100 is nothing but that number of nanoseconds, 1 nanoseconds or picoseconds format, right? So this is a predefined code that is given by the software module name, register ABC. That means ABC variables can be used as a register variables in this program. Because of these three variables can be used as a left side variables in case of the procedural block. So for that purpose, you have to represent the ABC in the register type. As well as output variables can be represented as a white type. Previously also in case of the half adder, we can use sum and carry variables used as a white type, because of white means that it is the output point of view. So full adder program, this is a module name already given in this program. So that is nothing but module name. So this is a module name program. So module name can be given in the module program. Now the same module name can be instantiation in the test bench also. That means if you are writing the module name, obviously the same logic can be included in the test bench also. By using the corresponding logic, it performs the operation. So initial is a it is a procedural. Initial is the block of. Initial is a procedural block. Procedural block means that it consisting of some set of statements. So begin is the starting of the statements and end is the end of the statement. So in between begin and end, we have some lines of code is there. This is generally called as a statements. Okay, this is generally called as a statements. We have a two types of statements, that is nothing but blocking and non-blocking. Blocking statements means first by executing the first value, then it will go for the second value. In case this is a way of blocking methodology. So in this initial block, in case any variables are using in the left side of this equal operator, that variables must be a register type. Okay, so that is the important criteria. So here wait 10 nanoseconds for the global reset to finish. So that means it is the delay used for the corresponding input combination. That means after 100 nanoseconds, you can take the another combination. So initially A is equal 0, B is equal 0, C is equal 0. So another possible ways for giving the input where A is equal 0. So B is equal 0. C is equal to 1. This is the one combination, right? After that, A is equal to 0, B is equal to 1, C is equal to 0. C is equal to 0. So this is a one more combination, 0 0 0 0 0 1 0 1 0 0 1 1. So A is equal to 0, B is equal to 1, C is equal to 1. Next, A is equal to 1, B is equal to 0, C is equal to 0. This is the one more combination. Then A is equal to 1, B is equal to 0, C is equal to 1. This is for one more combination, 5 actually. So as well as 8. So 1, B is equal to 1, C is equal to 0. One more combination, last combination. So A is equal to 1, B is equal to 1, C is equal to 1. So these are the different ways we can give the input for full adder. So totally combinations is equal to, in case of the full adder, we can give the input combinations in the 8 possible ways. So that can be represented as 2 power n possible ways, where n is equal to number of variables, where n is equal to 3, therefore 2 power 3 is equal to 8. That means we can give the input combinations in terms of 8 combinations. So total number of combinations is equal to, this is one combination, right? This is second one, third, fourth, fifth, sixth, 7, 8, total number of. So obviously this delay is important. After performing the, after 10 nanoseconds, 100 nanoseconds, we can take the another input command. So after giving this first one, give this certain delay. So for that purpose I have to include a delay. So perform the delay and take the input. So here also I can mention this is also delay, this is also delay, right? Now we can, this is a, so test bench means just we are providing the input combinations, we are providing the inputs to the full adder in the different possible ways. So by using the A, B, C variables, how we are going to give the input combinations to the program. So let us check whether this program is correct or wrong. Syntax